All right, welcome back. July 14th. Today we're going over notebook 15, and I'm going to pause and go back and talk about a couple of things while to give you a chance to re-download it. There were, if you've already downloaded and run it or not, there were some changes to Seaborn over the last couple of years that I incorporated into the new version that's on the classroom right now. But I did leave one deprecation method to kind of show you what that looks like again, just for giggles. So download that, and then I've got a couple of other techniques that people brought up that I wanted to show. And Seth's not here. He asked one of the questions, but I'll show you what I found out right now. He wanted to increase the size of plots in Jupyter Notebook. And there's a couple of settings, just 2 lines of code that you can put at the beginning of a Jupyter Notebook. And I'll show them to you as I go into my notebook directory and pull up. I think I put it in here. Yeah. So this is notebook 14 that we used on Tuesday. But there's 2 changes here, 2 lines of code. One is it's called a magic command. And there's lots of information. If you're working with Python and particularly in Jupyter Notebook, there are it's kind of like environmental variables that set things, and you put a % at the front to indicate that. And then in our good old PyPlot plot module, there's a figure size setting that will make the plots in Jupyter Notebook bigger. And from what I could tell, if you're working in an IDE like Spider or Eclipse or whatever, you don't need this matplotlib inline. But if you're using Jupyter Notebook, it works better. But I'll show you the effect of this. If you kind of look at the notebook you have and look at the plot, or remember the plot sizes, they weren't very big, and Seth wanted to know how I could make them bigger. And so I'll run these code cells. In fact, let me run all, and of course we'll get our errors like we did last time down the way. I still have not sorted that out. But now you see how much bigger these plots are now. That's because I set the, let me go back to the top. That's because I set plot.rc params figure size to 12 and 8. It defaults to a little bit smaller than that, like 8 and 4 or something like that. And that's supposedly inches, but it's in the documentation for PyPlot. But 12 and 8 seem to be the right combination of horizontal and vertical for my display and my monitor. So yeah, that's how you set your figure size in Jupyter Notebook. Magic command and an RC params setting. So yeah, and it makes them more visible. So I'm going to try and remember that. And I'm going to leave this notebook open and implement that. In fact, I forgot. I did all these changes to notebook 15 over the last couple of days and forgot to put that in there to make the plots a little bigger. So we'll goof around with that too. And then the other cool thing was Alyssa found the margins. Let me bring that notebook up. And I did post this new notebook to the classroom. Modules. Um, you'll find a second notebook 13 on pivot tables. That shows you how to do a grand total, and then using Panda's data frame stacking, you can create subtotals for each of the. I'll show you rather than talking about it. So if you bring up Panda's pivot table subtotals, it takes a little more work than you might think. Let me run all just to be sure. Run all. Okay, so this is the same notebook, except down here where you first see margins equal true and margins name. That's new. And that was creating a grand total. I think that's new for doing subtotaling, because it automatically pivots on the things in the index parameter. That's this index equals list, remember, is the things that you are pivoting, branch, and then whether it was opened by new accounts or teller. And that gives you these little subtotals, but it doesn't give you, I mean, these, that's what gives you these summed aggregated amounts for each of those. And then the margins equal true. And some of these parameters are just not very intuitive, but as Dr. Ellis likes to say, if you if you don't like it, write your own library, and you get to pick the names and the way everything works. So there you go. They call it margins. I'm sure there's a reason for that. I'm sure there's some genesis to that term, but that's how we got grand total down here, is by saying margins equal true, and then we can I think it defaults to the word all for the total name, but you can change it with margins name grand total. And then there was a great article in Toward Data Science, which is actually a paid site. If you hit it too many times in a certain period, it wants you to subscribe. But luckily, I got in there before my my number of hits ran out. And this is a user-defined function, and I've mentioned this before. You can write your own functions that you can then call, and this is an example of that. And it's really a fairly simple for loop with some if-then-else logic, and then it is stacking. It's building a small pivot table based on the index values you send it. And it's building multiple pivot tables for each of those levels, and then appending them into one data frame, because a pivot table returns a data frame object. And you can stack similar data frame objects on top of each other into one data frame, concat them into one data frame. So that's what this thing does. It loops through the indexes that you send it and builds a data frame and stacks it on top of each other, and then adds the grand total. So when I call it with the same stuff, now I'm calling this user-defined function that that's in this big cell here. And when I pass it branch and opened by, I get uh, the grand total of all amounts in this top row. And now I get a subtotal by branch, which I didn't get before. So yeah, pretty cool. But I couldn't find any built-in way to do this. That gentleman's um, article on Tor Data Science was the way I saw to create what looks pretty close to an Excel pivot table with subtotals and a grand total activated. So I wanted to share that, and I can't remember if were there any other open issues or questions. Anybody? If not, I'll move on to notebook 15. All right. File, save it just in case. File, close and hold. And today's notebook is much more focused on Seaborn. And again, I modified it pretty good bit since the initial file that was uploaded to the classroom that's been there the whole time that we've been meeting. I just uploaded it this morning, so you're going to either want a fresh copy, or we can talk about what changed. But I'm just going to concentrate on this new version. Okay, so part 2. We don't need any files this time. We are just going to use a Seaborn built-in data set. And remember, the ability to create a plot doesn't mean you need a plot. Not all plots work for all data. There you go. So Seaborn is a library that does some automatic magic. It's like an interface to Matplotlib, which is the lowest level, highest amount of control, with the most amount of parameters and whatnot, is down at Matplotlib. Well, Seaborn brings in Matplotlib and then presents to you kind of some shortcuts, kind of like Pandas does with NumPy. It does a lot of things that, because it's user created functionality. So you don't have to. So it's kind of auto magic interface to Matplotlib. Okay. And some other stuff. And there's the actual documentation for Seaborn, which I spent quite a bit of time in. Interesting, just learning about all this stuff. All right, so we'll run that. We'll bring in Seaborn and Matplotlib. And Seaborn automatically uses Pandas. So when you open up a data set, it returns a data frame, but you don't, and you get all the data frame methods and all that, but you don't have to actually import Pandas, unless you're doing other Pandas stuff. Okay, so we import those libraries, and we load in that data set that had the tips data set. It had the total bill and male, female smoker and all that stuff for restaurant bills and the time of day. Remember, lunch and dinner. So we loaded that. Now these are Seaborn calls to graphing methods, graphing functions. So we use SNS dot instead of like plot.show, plt.show. That was the call into Matplotlib's PyPlot module. Well, we're calling we're calling these functions from the Seaborn library. So we say SNS. Count plot is a bar chart, which it counts the number of occurrences within each bar. But it's nice. It makes it really pretty, just like that. And we can add a grouping, a secondary variable with a parameter called hue. Hue to me is color. I couldn't, in all of my reading, I didn't see why they called it hue instead of X or secondary or something, you know what I mean? But it's not. They call it hue, and that's a secondary variable. So these are two parameters that you got to have. You got to have an X, and you have to have data equal a data frame whenever you call count plot. And if you assign it to a variable instead of just doing the library and the method, if you assign it to a variable, you don't get this this little summary statistic up here. So it can kind of cleans it up. It's almost, and plot.show has the same effect. So like I said, there's so many different ways to do the same thing in but another useful feature, automatic feature that comes up when you assign the axis object, which is what this plot is, to a variable name, you get a legend for the hue variable. So this tells you, like right now, we got male and female, but without the legend, you can't tell what blue, orange, green, and red are. So when you, like I said, when you assign it to a variable, you get that. If I take that away, I did so much playing with this stuff. I want to say, yeah, assigning it to the variable got rid of that summary line at the top. It got rid of this junk, which is interesting, but not something you'd want to save to an image. So that gives us our hue, and there are other parameters, many other parameters. You can order the categories, do lots of other stuff, but that's a basic bar chart with a single variable and a subcategory, two variables added together, and one line of code. I mean, it's pretty good. So a scatter plot, we got to have an X and a Y. Remember, we're comparing two variables, but there's no plot.scatter in Seaborn. It uses two very similar function calls, but they work differently. LM plot, you'll see some examples here. LM plot is a figure level call. Oh, hang on just a sec. That one took a minute to build. LM plot is a function call that lets you build an entire figure. So it's a figure level. It stands for linear model. It's a figure level function that lets you build what you can have multiple plots, kind of like we had in that Anscombe with the 4 different scatter plots. It's similar to that. It lets you set up a matrix of subplots. And then there's another one called reg plot that looks a lot like it's the subplot that just does a scatter and a line of best fit regression line. Okay, so Alyssa, that was you. Are you on? You are on, right? Yeah.
Yeah, I'm right here.
Hey, yeah, and Alyssa, in her homework, did it's about 2-3 lines of code in Matplotlib to use a regression line. You kind of have to you have to sort of calculate the regression and like add that calculated line to the plot in Matplotlib.
Basically what I saw, from what I could understand, because like I hadn't seen the code before, you, like you said, calculate it yourself using variables and other things, and then you plot that trend line, and then it will plot the line in the same scatter plot that you created.
Yeah, and it's only 3 or 4 lines of code. Do you mind if I show your homework?
Yeah, that's fine.
Just real quick here. Go to downloads and sort by last modified. The other direction. And I went through everybody's homework yesterday. Did you?
I forgot to put my name in.
You did forget to put your name on there.
Yeah, it might be the one that's just the name of it.
I think it's the first one. I think it's this one. I think. Because I think it comes up alphabetically. Alyssa, yes, this is you. Okay, so adding the plot line was this, or trend line, yeah, was this bit of code down here. And Alyssa, did you find that at a particular tutorial site or in the documentation itself?
I think I just found an example code online. I don't remember this site. I could go back and look, but I just found it online.
It's not important. There's so much resources out there. If there's something you want to do, generally speaking, you can find it out there. You just gotta Google it and make the code work. Figure out what they're doing in their example versus what you're doing with your data, and kind of adapt it. But yeah, so what do we got there? Really 3 lines of code that calculates the line of best fit using NumPy, which is an underlying library of pandas, but we've included it here natively as NP, and then it sticks it on the plot as part of the scatter diagram. So Seaborn, now if I can pop back over to notebook 15, Seaborn does that for you by default automatically with this linear model plot, which is really just the same as a scatter diagram. But LM-plot, remember I was saying, is a facet grid. They call in Seaborn, they call the matrix of subplots a facet grid, and each one is a facet, but they're also called axis level. Like you have since you have 2 plots here that I just drew, total bill at lunchtime and total bill at dinner time, each one of those is an axis level subplot. So the way you would modify things, you just got to keep that in mind. And if you're working with Seaborn, you'll get familiar with this stuff. But I don't sweat it, for the level that we're learning in this course. But that's what we did here. We said X, and again, this linear model plot, X is total bill. So that's why we have 2 plots for total bill but they're broken up by uh, um, tip and smoker. And then we have um, um, column says that we've got these two plots for the different occurrences of time. So if there were like time only has lunch and dinner, so we're only getting two subplots. There are two unique values for time in the column parameter. So we're getting two plots for two columns. Um, yeah, of the total bill, which is the X parameter. So yeah, so now we're looking at the total bill correlated with the tip, which generally speaking always correlates, right? But we're breaking that apart um, uh, with our hue parameter, which is kind of where you see how that makes it two different colors. So we're saying hue equals smoker. So now it breaks smoker yes or no into two different colors in our scatter plot so that we can now do, bivariate analysis based on whether or not smokers tip better or not. And it looks like non-smokers tip at a higher rate. I think that's what we're looking at. I think that's what that shows us. And of course, you can look at the number of dots. You can tell just by looking at this plot that there's more traffic, more tables being sat at dinner. So yeah, so each of these two scatter plots are axis level, X and Y, axis. And then you've got so here's some more explanation about that. So there are some things that you set at the figure level or the facet grid, like the overall title, versus setting things for the individual subplots. Okay, so that's how Seaborn treats and we've got I got a couple more examples down here. Okay, histograms, density plots, and rug plots. In this section, if you're running the old one, or if you spent any time running the previous version of Notebook 15, you started seeing some deprecation warnings because they changed a call called dist plot to dist plot and hist plot. So one's figure level and the other's axis level. All right, so a histogram in Seaborn. We'll set that, and that's just a histogram of our total bill. So we can see that the bin with the highest number of frequencies is about what, $48, and it tails off into smaller into larger parties, larger bills. There you go. But your highest occurrence is right about here. What's that, about $12? And we saw that before. So there's that. And I want to say, if we move these two lines of code, I'm going to comment it out there, and I'm going to put it in here. Yeah, we get rid of our summary statistics. If we do the assignment afterward, it's kind of like that assignment call has the plot.show in it. It's weird. Yeah, so there's that same histogram. Okay, so there's another feature to a histogram that's kind of like a a smoothing line that goes along with the histogram that looks a little bit more like your bell curve, a normal curve or a skewed curve, whichever, but it's the line. And we do that, we add that to the histogram by saying KDE, kernel density estimate, but it's just a density plot is what you see a lot in the literature. So we'll run that, and that adds our smoothed density curve to the histogram. Using using hist plot, which is an access level function call. Density plot. Now this is just the line is a KDE plot. So there's three different. There's hist plot, rug plot, and KDE plot that are the axis level function calls. And LM plot is the one that lets you create a matrix of any of those sort of things. I think we get there here eventually. So here is, and we can set the title, with the set title command. So that is really that without the histogram. And that is that without the density plot. So you got kind of ultimate flexibility depending on what you need. And a rug plot is really just a tick mark kind of representation of each. You get a tick for each occurrence of the value going along the x-axis. And of course, good old, you can call plot.show, which will do some of the same things that it did before. But here you get this rug plot. These tick marks at the bottom show you the density of the data, and depending on the scale and the size and everything, it just turns into a blur. But that's a good segue into why we use a hex plot instead of a scatter plot, because once the data becomes sufficiently dense, you can no longer see the effect of each data point. Rug plot. Oh, I wanted to do that magic command real quick and see what. Curious if I stick that in the middle of a notebook, what'll happen. What the heck? We'll find out. We got 7 minutes till break time. Let me go back to and grab my magical stuff here. Don't really need to comment, but I'm curious. I had to play around a little bit with this to get it to work. But now if I insert that in this cell, so look how, so that's how big it is now. I'm curious if it will. Yeah, there was something I needed to do that was like the plot.params had to come after something. Plus, we're working more with Seaborn here. I'll come back to that. Just get rid of that stuff. I didn't have a chance to experiment with plot size and Seaborn. But this is a combination of all three univariate. So we're only looking at one variable, right? Total bill. And these are three ways of looking at the distribution of that. They're redundant. I don't know when it would be informational to have all three of these together on the same plot, because it's all looking at the same variable, total bill. But that just gives you an example of how those are built in Seaborn. Okay, so that's univariate, just looking at how the data is distributed. And again, categorical is pie chart and bar chart, and continuous variable is normally a histogram or a KDE or a rug plot or a hex bin. I think we got a hex bin coming up here. Bivariate data is, I'm sorry, hex bin is bivariate, not univariate. Okay, so there is no scatter plot. Like I was saying, there's no SNS dot scatter. So we use LM plot to build either a single or a matrix of subplots, and reg plot, I believe that stands for regular expression, builds a single graph, a single chart for you. And here's an example of a scatter plot with regression line using reg plot, and it's pretty automagic. You have three mandatory parameters: the x-axis, the independent variable, the tip is the y-axis, the dependent variable, and then you have to tell it what data you're talking about. So data equals is a data frame, which is the tips data frame, and then we can adjust parameters for that reg plot using these methods. Because of reg plot, if you use, there's different parameters for LM plot, even though they're both scatter diagrams. Once you get kind of familiar with working with both of them, you can tell the difference in the documentation. I had to bounce back and forth between the both of them a little bit. So yeah, scatter plot of total bill and tip is set with the reg plot title. And this shaded area, it comes in by default. It's a 95% confidence interval. So you can see that if you were doing, an actual linear projection of this thing, saying, okay, well, what if total bill was 100, way out here, way out to the right, your confidence interval of your ability to predict that would get broader and broader, because the data gets broader and broader as you go up. So that's an interesting feature, a confidence interval laid on top of a line of best fit, or a linear regression. You can do, there's other lines that it will try and fit on there, which I think we'll get into when Dr. Ellis does our session on August 2nd, because he's got to do some regression stuff. Okay, so scatter plot with regression line using LM plot looks very similar, but it's a different call. Very similar. This one, you can make a matrix of reg plots, and with using LM plot, you can set up a group of them. And then we have, the hex bin. We talked about this last time. Sometimes these dots get so dense that it just turns into a plop on the screen, and you can't really tell just how many data points are underlying because they get so dense in one area. So a hex bin is kind of like a histogram, where it bins the dots into a hexagon, because a hexagon, they fit together into a honeycomb pattern. So if a dot falls into the geometric area of one of the hexes in your hex bin, it gets darker, and it starts to count them up, and the more data points that you have in that hex bin, the darker it gets, and then you get a little bit more fidelity into it. And this starts to show you kind of the power of Seaborn. So we've got this joint plot that will do a hex bin and a histogram that kind of shows you even more information. And we've got total bill and tip, and you get the histogram for total bill, and then you get the histogram for tip. But inside of the hex bin, you can start to see the no kidding density of these typical checks, that lunchtime, that $12 check that we saw in the other chart. So yeah, hex bin. Your typical, your typical checks down here with a $2 tip on top of a $12 tab. But they start to stack, and you can't really tell just how many of them there are. But a hex bin will add a little more clarity to it. And I want to say, I'm looking at this now, and I'm curious if I'm wondering why there's not a legend for the hex bin. It's got to have something to do with the order of this stuff. I wonder, and sorry, I'm going off script here, guys. We're going to go on break in just a minute or two. If I comment that out and I put it in down here, do I get my legend now? No, I don't. There's got to be a way to make the color gradient, I think. Anyway, there's got to be a way to make that color gradient come out. Anyway, yeah, hex plot. That's what that's good for. When you got too many dots to be represented effectively by a scatter plot. Okay, and box and whiskers. These are, you've seen these before. These show you basically the same thing. It's the same information as a histogram, and we're going to do two variables here: the time of or two box plots separated by time on the x-axis. You'll see that. So we've got time on the x-axis, which breaks out our lunchtime data from our dinner time data, and it starts to show you, like we said, your median check size at lunch is smaller, as you would think, from dinner. There's all kinds of things you can play with there. Okay. And this line of code is incredibly powerful. I don't know how you would do this, but you set up basically a matrix. It takes a second or two to execute, but you set up a matrix of subplots. So you can, it takes every numeric variable, every continuous variable, and subplots them against each other. And yeah, like party size, that starts to look like discrete because it's an integer value, and there's not a lot of them. It's not like there's 1 to 700 party size. It's only 1 to 6. So you start to get these what looks like a categorical variable, but it's not really. But anyway, and then at the intersection of tip, like in the middle here, this center square is the intersection of tip and tip, right? So you can't, that's the same variable. So all you get is the histogram where the two variables intersect. Size and size is in the lower right corner. See how that works? And we'll see in a second. There's a way to say if that's going to be a histogram by default or a density plot. Depends on how you call it. So yeah, and I've got another example next hour. Whoop, and I'm way past break time. You guys need to hush me up. We'll got a couple more cells. Yeah, got a couple more cells, and we'll continue at 9:35. You would have already interrupted me if there were any questions, right? Okay. And there's when you're putting more and more variables like we saw before with the hue, there are ways to tell the viewer would, the different variables. You can break things out into different plots, but on top of the same plot, you can change shape, size, and color of different objects. I had an example of size, but it kept erroring. Like I said, Seaborn has changed in the last couple of years, and I couldn't get the size of a marker in a scatter plot to work with Seaborn. So anyway, I pared things down a little bit. But here, yeah, we'll get started again. Run this one. We can use the hue parameter of a scatter plot, well, LM plot, linear model plot, to show the difference between data points in the same scatter. Right, this is all just total bill compared to tip, but it instead of treating them all equally, it colorizes each data point as to whether or not it was a male or female pay in the tab. So that's one way to use color to differentiate. And I'm sure if there were other categorical data like that, we could throw them in there as well. In fact, I want to try that. I want to give you time, so not going to fool around, not going to play with it. Okay, not on your time, your clock. And yeah, pair plot. Yeah, that's where we have a matrix. So pair plot, if you use the hue parameter, because now this is the same thing as we had before, but we're breaking it out by color, and you'll notice it uses, by default, it uses a density plot instead of a histogram in the intersection where total bill and total bill intersect. It breaks them out into two different density plots instead of two different histograms. You can change that. There's a parameter in the Seaborn documentation if you really want a histogram, but I think the density plot might be more informative. It might have like less where chances of the bars in a histogram overlapping each other. So that's how you would break out data in a pair plot by a categorical variable. And then you can change the shape of your markers so that it's easier. So now we got color as well as shape of the marker, which helps it stick out to the viewer. Makes it more apparent. And we've turned off the line. Just for example, we've turned off the line of best fit here, just to make it less clutter. Or if you, for whatever reason, you don't want a regression line, fit reg faults. Okay. And then uh, uh, Seaborn creates a set of subplots, and that whole thing is uh, uh, a facet, and um, Seaborn kind of just loads everything in yourself, or automatically, um, with LM plot. You don't have to create, like, remember in Matplotlib we had to break the the Anscombe data set down by which data set it was, Roman numeral 1, 2, 3, or 4. Um, uh, with uh, with Seaborn, it starts to do some of that stuff automatically. So this is with just a couple lines of code, we're recreating that plot that we did Tuesday, um, automatically with these parameters. There you go. And you can see, like, for example, um, this one data set where all the values are 8 except this one outlier. Uh, the um, the confidence interval is a lot wider, than maybe this more typical one that's just got a little bit of noise um, outside of the trend line. Okay, and then there's so much more. uh, there's a if I'll post it. There's a tutorial that goes through every stylistic change, every plot type, um, that you can do with Seaborn, and they're in Jupyter notebooks, and it basically goes like chapter 1 through 13. You can just read through and play with all of these visualizations. Okay, so cool. You can draw these simple plots with one line of code. So don't get, too worried about some of these more complex visualizations unless you want to. But generally speaking, you can do something informative with, like this simple one with one line of code, just like you could with Matplotlib, only Seaborn makes things a little bit more automagic for you. But between uh, the basic plots and Notebook 14 and Notebook 15 here, you've got plenty of code examples that will let you do just a free form exploratory data analysis, which is what we're going to do next. Is I'm going to give you time and a very loose mission, in order to put this stuff in order. So what we're doing is combining now the wrangling stuff that we learned with Python data wrangling or notebooks 9 and 12, and maybe some in 13. Maybe a pivot table will help you, and this charting. And I want you to wrap all that knowledge up and do an exploratory data analysis, a free form, do whatever you want, just like we did with Excel. But I want you to use Python and Jupyter Notebook. And I'll show you an example of what I'm talking about. And then I'll let you go to work on it. Cell all output clear. Checkpoint. File close and halt. Okay. So what I've got here, and I will upload this to the assignment when I'm done here, is a notebook I developed that is just a real simple sample exploratory project. I used a Seaborn data set that is replicated on GitHub. after looking through what there was to offer and looking at Kaggle and whatnot. And this is also out on Kaggle. And I just kind of ripped through, and this is just free form. This is just to give you time. And like I said, a loose mission, direction, purpose, so that you can get in and start hacking away with this stuff. Practice makes perfect, and there's no wrong answer, guys. I mean, this is just a chance to give you some hands-on practice with what we've learned, so that you have a little more confidence and familiarity. So the deeper you want to go, the better. But a little bit is fine too. A little bit of analysis is going to be fine with me too. So I think by the time it's all said and done, you're going to have about 4 hours to work on this. So you should be able to get through some cool stuff. Again, we're going to combine wrangling and graphing. Okay, so hopefully you'll show me that you've got it. You got a handle on both data frame manipulation and visualization. Okay, so for this one, I'm only using Seaborn, Pandas, and Matplotlib. What I would like you to do is, and this is just this first block of code is just to loop through the Seaborn data sets and do a df.head on each one of them. And that's just a quick bit of code that lets you sort through them. There's about 16, I think, different data sets. Okay, so after you have decided what you want to explore, whether it's NBA scores or gun ownership or whatever the case may be, and if you want to use the same data that you used in Excel, I don't mind. If you're familiar with it and you thought it was cool and you wanted to do something like that, I just would hope that you're able to extend that data set so that you can show just a little bit of data enhancement or data wrangling using Python. So once you've chosen what you're going to do and what you're looking at, write a little markdown cell as to why. This is just real simple markdown. So, and you can use this notebook as an example. Just kind of given a brief overview of what we're looking at and why. Okay, and mine is on automobile accidents. So I use the auto accident car crashes data set, and again, this is just for practice. So don't sweat, why you're doing what you're doing or anything like that. But I decided, okay, car crashes, that looked cool. It was fatal car crashes and some other supplementary data, which I'll show you right now. So step 2, we begin collecting data from sources. So built into Seaborn, we have a car crashes data set that I read into a data frame, DF, and I printed out the descriptive statistics and then all of the rows. I knew it was state level data. I say first 10. I changed it to 60, I guess, since I used this thing. And that prints out a lot of stuff. So we got a scroll bar down here. So here is the data itself. There's a total column, a number speeding, a number where alcohol was involved, a number where they were not distracted, whether they had no previous accident. And these are aggregate statistics. These aren't individual observations. It's aggregate statistics by state. And then we have the insurance premium and insurance losses for each state, Alabama through Wyoming. So that's the car crashes data set in Seaborn. Okay, so I went out to Kaggle and I found the data dictionary that describes what each column was, because it looked good in this notebook and it helped me understand what I was looking at, particularly what the total column was. That was the number of drivers involved in fatal collisions per billion miles driven. So it is a it's not a raw number, which wouldn't be fair to compare California to Wyoming. So it's per billion driving miles. And then these are the speeding, alcohol, distracted, and no previous. Those are percentages of the drivers involved in those fatal collisions. And again, this is all going back to the 09, 2012 era. So it's not data from the exact same year. So it could shift around a little bit. And that's, like for practice, that's fine. Okay. And then we go into our, like I said, we're collecting data from sources. So we're just grabbing this stuff and bringing it into data frames and doing some wrangling. So I got a DC column. I want to do 50 states because I don't always have other data for DC or Puerto Rico or other territories. So I got rid of DC and did another df.head. There's no Washington DC anymore. But as I went through this, I noticed that Iowa was out of place alphabetically. It's indexed. This is the index 1, 2, 3, 4, 0 through 49, but it didn't look like it was alphabetized, which troubled me because I wanted to add a column, and I can't necessarily count on another data frame having the exact same error with the index and the alphabetization. So I sort it. That's always smart to sort the data so that the indexes, if you bring in another data frame of states, the indexes will be the same, which is how it does the merge. Okay. So this is nothing new. We did this in data the data wrangling exercise. So I basically just sorted it and re-indexed it. And now Iowa is where it belongs here before Idaho alphabetically. And it renumbered the indexes. And again, this is just basic data wrangling. So I wanted to bring in some stuff about age. So I went out to Wikipedia and found a state median age table and massaged it and turned it into a CSV. Instead of doing all of that in here, you know what I mean? I just pretend I had a clean data file for age. So yeah, read that in, sorted it by state to make sure that everything's all square, and reset the index and take a look at it. And now we've got Alaska down to Wyoming in the same alphabetical order by state abbreviation. And now we have median age for all residents of that state, as well as median age female and median age male broken down. Well, I only wanted median age. So I went ahead and deleted those out of the data frame, which is always good practice to just get rid of distracting extraneous data. So I deleted those, printed everything out to make sure both data frames looked good. And I was happy that they were in the right order and had the same number of elements and everything was lined up right. So I concatenated them side by side, and it uses the index of each data frame to do that. So we got Alaska from the original car crashes database lined up with Alaska from median and age, Alaska, Alabama, Arkansas, all the way down. So I've added median age to the appropriate state. So now I got 2 state abbreviations that I don't need them both. So down here, I got rid of abrev. So now I got my car crash data and the median age involved. Just again, this is just practice. This is just what I could think of at the time to kind of help with my own practice and to give an example of the kind of thing that you could do for your project. Okay, and then begin analyzing data, and that's however you want to do it. I thought looking at things, sorting can, then you look at the lowest and the highest, can give you some information. So Massachusetts, of all places, has the lowest number of fatalities per billion miles driven. Not really sure why that is. This is exploratory, not explanatory. But looking at something like this, where Massachusetts has 8 and North Dakota has and South Carolina have 23.9 fatalities per billion miles driven. So is that 3 times? 3 times as many deaths per billion miles. Again, I mean, assuming you can trust the data and whatnot, and I think this is relatively realistic data. But that would be a candidate, and this is not what I'm asking you to do for this assignment, but that would be a candidate to go explain and do explanatory data analysis as to why that is. You could look at factors like driving training, how many years you have to have a learner's permit before you get your actual license, whether driving training was mandatory or not, or if you just go take your test, those sort of things. You could look at number of snow days, I guess, might cause accidents. But we've got things like alcohol and whatnot, so we can kind of correlate the total number of fatalities per billion miles to whether the percentage of people that were using alcohol. So we've got some factors we can look at, but explaining even this would take, that'd be a whole nother project. And we're just doing explore. We're just goofing around with data here and charts. So I'm also looking around, what are, insurance premiums looking like at each state, and drastic difference in average insurance premium between, say, like New Jersey and I think it's Iowa. Yeah, Iowa and Idaho, way down here. Less than half of your average insurance premium in New Jersey, which makes me wonder what is going on in New Jersey. So let's see what else I did here. So later in the, I'll do some correlations, some graphing later. So I created a calculated field that was premiums minus losses, which is basically profit. And then so that I could correlate the profit to the other things like the total fatalities and whatnot. So I created a calculated column of crash DF insurance premium minus insurance losses, and then resorted everything and printed out just the state and the profit. So coincidentally, the high New Jersey with the high insurance premium is also the highest profit, which I don't think that should necessarily correlate. They're charging more and making more because they can, I guess. I don't know. So anyway, that's what I found out. Good grief. Why is Jersey so profitable? And well, that would be um, more of an explanatory project, but I just wanted to look at, that insurance profitability versus other things. And if we look at uh, a histogram with the a density plot of totals, it's fairly flat. It's not, it doesn't it doesn't peak real well. So there's a pretty wide dispersion in that total fatalities per billion miles driven. So I drew that out. But then what I wanted to look at is, since we've got these different variables, I wanted to look at them all, and this just kind of shows the power of one teeny line of Python code. Is you get these scatter plots, and I hope you are you're looking at the notebook and not at your screen, because this is tiny on my screen. I would imagine it's teeny tiny on your screen. I don't even know if, because there's so many variables that are being plotted here against each other. So remember, this is a matrix of bivariate analysis. So up here in this first one is the total. That's your total fatalities, and then it compares it. The first column is also total. That's why there's a histogram here and not a scatter plot. But it starts to go over here and compare and correlate total to every other numeric continuous variable in the data set. So you start to see, just looking at, without even scrolling down and looking at the x-axis, you can start to see that some of these are just not correlated at all, and some of them look extremely tightly correlated. And you might start to wonder what is so closely related to total fatalities. It's like for column 3 and 4 look really well correlated. But anyway, that's what, so you've got a matrix here, the same number of variables on the y-axis as you do on the x-axis, and you've got a matrix now of scatter plots, which will be, and there's, each one will be duplicated, right? Because there's two places where they intersect, X and Y. Does everybody see that? This scatter plot of insurance premium and insurance profit is duplicated over here where we have insurance profit and insurance premium on the y-axis. So you'll see the same plot on here twice. So that's how that works. So there are some interesting correlations here. Premium and profit appear to be tightly correlated. And like I said, I don't know that should be true. In fact, it should be negatively correlated to me. If you have to charge more, it should be just to cover your, so that you don't go out of business. But it seems like they're just, I don't know, bilking people. Maybe I'm not an insurance guy. I don't know. It just seems counterintuitive to me. But anyway, this is just practice. So I didn't want to get too wrapped up into the reality of this stuff. I just wanted to play with some graphs and data frames. So some interesting and unexpected correlations. So I got a few individual scatter plots here. Here is total of accidents by insurance losses. Doesn't appear to be correlated at all. I would think, if, in a place that had a bunch of dangerous drivers, you'd be losing money. But I guess they have done their risk analysis pretty well, and adjusted premiums accordingly. I don't know, but that doesn't seem right, because we'll see that in a minute. Premiums and total deaths don't seem to be correlated at all, which I would think they would. The deadlier states, I would think would have the higher premiums, but that's not necessarily true at all. There's almost no correlation, total and insurance premium. And this scatter plot, well, because it's an LM plot, it's a figure level plot. We get the automatic regression line and confidence interval. But this scatter diagram here is the same one we see up here with total and insurance premium, which is the first column, and then insurance premium is right here. If you can see, hopefully you can see my mouse pointer. That scatter plot is that scatter plot. Okay. However, alcohol and speeding definitely correlated. If you ran the old one, I accidentally put speeding along the x-axis and alcohol on the y-axis, which is wrong. Alcohol would cause speeding. Speeding wouldn't cause you to drink, but out drinking alcohol might cause you to drive too fast. So I switched those around for this this version of Notebook 15. So yeah, as the percentage of alcohol use goes up, the percentage of speeding incidents goes up. And remember, these are aggregate functions, but each individual accident contributes to that aggregate phenomenon that alcohol causes speeding and speeding causes crashes. And there you go. Speed kills, as they used to say in the old public service announcement. There's another one between not distracted and no previous. And it's loosely correlated, very loosely, that the median age. Accidents are, generally speaking, a phenomenon of younger folks. Younger folks get more accidents, less experience, and this shows that somewhat, a little bit of correlation, not terribly close. In this next code cell, I ran a correlation method, and you can choose if you're that deep into statistics, you can choose the calculation method for correlation. There's several. Kendall is a statistician you see with a few different techniques out there. But there's the difference between Kendall and Pearson. The difference in those two calculations for this data is only a thousandths of a point, just a minor difference. And that was just goofing around, guys. Like I said, there's just so the last portion would be interpreting the results. So New Jersey's profitability versus Iowa's insurance profitability. New Jersey has less accidents, less fatalities, but it's much more profitable. So yeah, perhaps there's a correlation there. There's where's insurance profit. You get more fatalities in Iowa, and they make less money. Perhaps they haven't adjusted profit or haven't adjusted premiums accordingly. Like I said, I'm not an insurance guy. This is really more about playing around with Python and being a little more comfortable with graphing and a little more comfortable with data frame manipulation. Okay, so just like the Excel project, I don't expect you guys to go quite as nerdy as I did, and I might have spent a little more than 4 hours on this, and I've got a bunch of good examples to go from. So you don't need to turn in anything as wild as this, but I'm going to give you the rest of today and probably a couple of hours next Thursday to do something similar to this. So let me clear all the output. You can run it yourself and save it and close and halt. And I will add this to the assignment as soon as we hang up. It's not currently attached to the assignment. While I got it up, any questions on what I'm looking for this next assignment? I want you to do something like what I just showed you. And it can be as grand or simplistic as time allows. No questions?
Hey, Don, I have a question.
Sure.
Would you recommend, like, if we use an external data set that we find online, would you recommend we like do data cleaning before importing the file to the Jupyter Notebook, or do you think we could practice cleaning it up within Jupyter Notebook using Python?
Would love to see you cleaning it up in Jupyter Notebook.
Okay.
Like I said, I cheated for this because I've already shown you data wrangling, and I didn't want to waste time going back through what I would have had to do to clean up that median age thing. I didn't want to take up your time doing what I'd already done in notebooks 9 and 12. But yeah, if you guys would show some data cleansing, it would warm my heart. Any other questions? Okay. So like I said, this is you're welcome to turn it in whenever you're done. Tuesday, we're Tuesday morning next week. The morning is devoted to NoSQL databases. It's called MongoDB. So if you've got a technical manager at work that you want to say, hey, I'm learning a little about MongoDB and NoSQL databases on Tuesday. Any application at work or any interest in the differences and whatnot, maybe a conversation like that might prepare you to put Tuesday morning's content more in context for you as far as your workplace. Like I said, its usage is growing and growing like crazy. Both MongoDB and which is a NoSQL database, and then there's a thing called a graph database, which looks at the relationships between entities, and who was a friend of who and who commented on who, and it's really good at looking at things like social media and other sorts of relationships of things. So MongoDB is kind of a next level technology past relational databases. So that's what we'll do Tuesday. And then Thursday, and I'll remind everybody about this. Next Thursday, I want to give you the first couple of hours, and we will convene late at like 10:30, and then I'd like for you guys to walk through your notebooks on Thursday and present the results of this. So I'll give you a couple hours today, a couple hours next Thursday morning devoted to this project. And like I said, doesn't have to be as fancy as mine, and it can be fancier if you really want to. Okay. No further questions? You're always welcome to email me or text me. All right, guys, I will get this attached to the assignment and upload it in the modules here within just a couple of minutes. And I'll see everybody Tuesday morning at 8:30 for MongoDB. Have a good weekend.
Don, I have one quick question.
Oh, sure.
And you might have touched on this, but you want us to work on it for the 4 hours, but can we work on it like longer? Like if we want to take breaks and then come back to it, or do you want it
Oh, yeah.
done by today? or?
No, not done by
Okay.
today. Done by next Thursday. So a week
Okay.
from today.
Perfect.
Yeah.
Thank you.
Yeah, sure thing. Okay, guys, have a good weekend. And again, please reach out if there was anything confusing, or if you want me to take a look at anything, shoot me an email, attach your notebook, whatever. That always helps. Instead of a screenshot, attaching the actual notebook works for me, because I can download it and run it and figure out what's going on. Okay, see you Tuesday, guys.
See you.